Look up at the night sky, what do you see? A blanket of darkness, sprinkled with tiny, shimmering lights. Each of those lights is a star, a sun many far bigger and brighter than our own. These stars gather into immense cities of light we call galaxies. Our galaxy, the Milky Way, contains hundreds of billions of stars. There are hundreds of billions of galaxies in the universe we can see. The sheer scale can make you feel small. But what if all of that, every star, every galaxy, every empty patch of space, was itself just a tiny, tiny part of something else? What if our entire universe was just a single atom in a much, much larger world? Have you ever looked closely at a fern leaf? You'll notice that the whole leaf has a certain shape. Look at one of its smaller branches. You'll see a very similar shape. The tiny leaves on that branch also echo the same pattern. This repeating pattern at different sizes is called a fractal. Nature is full of them. Snowflake, branching rivers, lightning bolts, microscopic blood vessels. The big parts look a lot like the small parts. It's an elegant rule nature repeats. So, what if the universe itself is a fractal? What if Earth's design rules apply on cosmic scales? The fractal universe idea, patterns repeat when you zoom in or out, an atom as a miniature solar system. Let's take a closer look at this startling comparison. On one hand, we have an atom. At its center is a nucleus, a dense core. Protons, neutrons, electrons all buzzing with energy. We keep finding smaller and smaller layers. So why assume the layers stop with us? What if our universe is another of these layers, a cosmic atom in a molecule that makes up something else, something beyond our comprehension? This journey of questioning is at the heart of science. We are explorers on a shore of a cosmic ocean. The waves bring new mysteries to our feet. The idea that our universe is an atom is one of those mysteries. It asks us to be bold, think big, never assume we have all the answers. If our universe is an atom, then it must be part of a larger structure, a cosmic molecule. And that molecule would exist in a larger world, a higher plane of existence. What would that world be like? What kind of beings might live there? Would they be giants so colossal that our entire universe would be an invisible speck on their fingernail? Would their hearts beat once every trillion of our years? For them, the entire history of our cosmos might pass in less than a single instant. They would be gods of scale. We can also flip the question. If our universe is a giant cosmic atom, what about the atoms within our own world? Every single atom in your body could be a universe in its own right. Each electron orbiting a nucleus could be a planet, teeming with its own form of life, its own civilizations, its own astronomers looking up at their sky. Now let's explore another idea that really twists our sense of reality. From the cutting edge of theoretical physics. It's called the holographic principle. To understand it, think about a hologram on a credit card. It's a flat, two-dimensional surface. But when you look, you see a three-dimensional image. The bird appears to have depth, the globe appears to have depth. Tilt the card, and you see different angles. All the information to make that 3D image is encoded on the 2D surface. It's a clever trick of light and information. The holographic principle suggests our universe might be doing the same thing. Everything we experience, you, me, the Earth, the stars, the galaxies, could be a projection. How do these ideas, the fractal universe and the holographic principle, change our place in the cosmos? Well, they fundamentally challenge our most basic assumptions about reality, calling into question the very notions of location, separation, and the fabric of space-time itself. For centuries, we operated on a simple map of the world, the comfortable, predictable universe of classical physics, a grand clockwork mechanism where every object had a definite place and path. We thought reality was what we could see and touch, a world built on solid ground where the rules were clear and the cosmos, while vast, was ultimately knowable. We believed space was the absolute stage on which the drama of the universe unfolded, and time was the absolute clock. But these theories suggest the map is wrong, or at least incomplete. They tell us reality is far more layered and interconnected. The holographic principle suggests the information for a volume of space is encoded on its boundary. This implies a profound non-locality, where every part is connected to every other, in ways we are just beginning to comprehend. The stage itself might be part of the play, and the universe far stranger than we ever imagined. If this idea is true, it means there is no ultimate up or down in terms of scale. The search for the smallest particle might be an endless one. The quest for fundamental building blocks becomes a journey down an infinite rabbit hole, because every particle could be a universe containing even smaller ones. Likewise, our universe might not be the biggest thing there is, but just one level in an infinite cosmic ladder. This shatters the idea of a final theory of everything. The dream of a single governing equation might be replaced by a more humbling yet beautiful realization. Instead, there might be an infinite series of theories, each describing its own scale. Our understanding can always be deepened, our perspective expanded without ever reaching a final, absolute truth. It would mean the universe is not a story with a beginning and an end, but an infinite poem where the same verses rhyme across endless stanzas. These mind-bending ideas aren't just born in armchairs, they are the product of tireless work by thousands of scientists around the world. These men and women are the detectives of the cosmos. They spend their lives gathering clues, building theories, testing them against the harsh judgment of reality. They build incredible machines to help them in their quest. Giant telescopes like the James Webb Space Telescope acting as our eyes, peering back in time to the dawn of the universe. They capture the faint light from the first galaxies, helping us map the cosmic web and test if it really does have a fractal-like structure. Other machines probe the universe on the opposite end of the scale. Particle accelerators like the Large Hadron Collider at CERN are our superpowered microscopes. We do not know for certain if our entire universe is just a single atom within a much larger structure. We do not know if our perceived reality is a complex, three-dimensional hologram projected from a distant surface. These are not established facts you'll find in a textbook. They are profound questions born at the frontier of knowledge, that wild edge where rigorous science meets the boundless power of imagination. So why are these seemingly unprovable ideas so important? Why should we dedicate our minds to concepts that lie beyond our current grasp? The answer is elegantly simple. The question itself is often more powerful than the eventual answer. It is the act of asking a bold, audacious question that ignites the engine of progress and pushes our civilization forward. The long, winding journey of trying to find a solution is where the real magic happens. It's in the failed experiments and unexpected observations that true discovery is made. Consider the ancient Greeks who dared to ask, is the Earth flat or is it a sphere? In a world that took a flat Earth for granted, the question itself was revolutionary. It compelled them to look at the world differently. They saw how ships disappeared hull first over the horizon. They noticed the curved shape of the Earth's shadow during a lunar eclipse. They even tracked how the stars in the night sky changed as they traveled north or south. This single question didn't just lead to the circumnavigation of the globe, it fundamentally changed our place in the cosmos. And what about the question, what are things made of? That journey led from the ancient idea of four elements, earth, air, fire, water, to the discovery of atoms, and then to the strange world of quantum physics which now powers our computers and phones. We are living in what can only be described as a golden age of cosmology. Never before has our understanding of the universe expanded so rapidly. Every new observation seems to unlock another layer of the cosmic puzzle, revealing a universe more intricate and magnificent than we ever imagined. For the first time in human history, we possess the sophisticated tools to not just ponder the most profound questions, where did we come from? What is the universe made of? But to actively seek out answers with a real chance of success. With powerful telescopes, we can look back to the universe's infancy. We can harness immense computational power to simulate the formation of galaxies on supercomputers. And in colossal colliders, we can smash particles together to momentarily recreate the extreme conditions of the Big Bang. In the grand scheme of cosmic time, we are like toddlers who have just learned to walk, taking our first stumbling steps into a much larger, more complex world. The cosmos is only just beginning to reveal its deepest secrets, and the epic story of discovery is far from over. Of course, the journey ahead will not be easy. Science rarely proceeds in a straight line. There will be dead ends, frustrating puzzles, and theories that crumble under new evidence. But each challenge is a lesson. But the human drive to explore and understand is a relentless force. It is an instinct as fundamental as survival, a curiosity written into our very DNA. We are the descendants of explorers who crossed oceans and continents, not knowing what they would find. Today, our spirit of exploration remains, but the frontiers have changed. The oceans we seek to cross are the vast distances between galaxies and the mysterious gulf between the quantum world and gravity. You don't have to be a physicist to be an explorer. All it takes is to keep your sense of wonder alive. Read, ask questions, and look up at the night sky to feel the awe of it all. Share that feeling. Talk to your friends and family about these incredible ideas. The more we as a society value this search for knowledge, the more we will support the bold endeavors that push humanity forward.